Hey, hello, geometry students. Here we are, beginning our second half and final three lessons of the semester in Chapter 5, 5.4, Triangle Mid-Segment Theorem. So let's go ahead and jump right in, learning some more attributes of triangles, kind of moving away from the points of concurrency that we saw in the first three lessons, and now focusing on three more lessons on slightly different things related to triangles. So here we go. We have just the two definitions. One is the mid-segment triangle. What is a mid-segment triangle? It's a triangle formed by three segments connecting a triangle's midpoint. So let's give ourselves a little bit of a drawing, but it's relatively self-explanatory. If you have a triangle, and then if you were to identify the three midpoints, so I'm just going to estimate here, but say roughly there, and here, then if we connect those, we create what's called a mid-segment triangle. So again, this would be in the middle here, this would be in the middle here, and this is the middle here. In our next definition, we'll kind of look at what's significant about that. But one thing I will just note is with this mid-segment triangle, every line is parallel to one of the sides of the triangle. So that top line would be parallel to the bottom. This line right here, in fact, maybe just putting these markings, you can see you have two parallel lines here. This line is parallel to that side of the triangle, and that side of the triangle is parallel to that line. So that's going to be important too, because we all know that parallel lines can help us through transversals and alternate interior angles find different angle measurements. And so I'm just going to note that here, that also creates sets of parallel lines. Oops, I don't need to write parallel, I just abbreviate it. Parallel lines with each side. Okay, and again, the way we form that triangle is by finding the midpoint of the three sides and then just connecting them. And so then we have the mid-segment, or the triangle mid-segment theorem, which says that a triangle's mid-segment is half the length of its parallel side. So let me just go ahead and recalculate, draw this in black. OCD says it's got to stay consistent. So we've got a triangle there. And again, we can draw the mid-segment triangle by finding the midpoints. Let's just maybe start with these two. Say those are the two midpoints, and I connect those. Okay, so that is a mid-segment, and so it's parallel. That's what I said a minute ago. These two lines are parallel, but that this distance here is half of the distance of the side it's parallel to. So if that's x, then the bottom here is going to be 2x. Or if the bottom is x, then the mid-segment would be half of that distance. Okay, so to kind of show another example, let me just draw another triangle. Let's just draw one maybe that looks a little different. Let's find the mid-segments. There, here. That gives us that, and that. Okay, so another mid-segment triangle. But what this is saying is that if I say I know that this here is 3, then the line parallel to that must be twice as big, so that this down here would have to be 6. And I'm just making up numbers, but if this was 2, then this larger side out here would be 4. And if this here was, we'll just say that's 5, then this larger side out here would be 10. So the mid-segment is always going to be twice or half as the length of the side that it's parallel to. And so that's going to allow you to find various sides based on these mid-segments, as well as, because the lines are parallel, you're even going to be able to calculate angles. And we'll be doing that in our questions now. So let's go up to our first question. First question is, if the side of a triangle is 10 feet, what is the length of the parallel mid-segment? So again, this should be very basic once you know that the basics of that theorem. If that's 10, and you can see that the mid-segment must be half of that, so 5 feet. All right, pretty simple relationship. Generally, if the bottom is x, then again, the mid-segment is going to be half, so this would have to be 1/2 x. Okay, so just making sure we get that very basic relationship between the side of a triangle and its mid-segment. And again, that line that I'm drawing isn't just some random, I drew a triangle and I'm going to put a parallel line there. Remember, it's at a very specific spot. It's at the midpoint of each side of the triangle there and there. Okay. And then, so our next questions are just several questions from the book, 3, 4, 5, 6, 7, and 8. And they're all just applying these principles to what can look like a very confusing triangle, but the relationships between the sides and the angles isn't that complicated once we break it down. So let's see, number 3 asks us to find NM. So let's find NM. So NM is right here. Okay, and you can see it's a midpoint of YZ and XZ. So which side is it? The key to finding that length is which is it parallel to? Because you could be tempted when you start solving problems like this to start filling in just random numbers. Well, no, find your parallel line. It's this one right here. So that means the longer line, the side, is twice as big as the midsegment. The midsegment is half of it. Alrighty, so 10.2, that means it's just going to be half, so that makes it must be 5.1 is NM. But what I'm trying to find. So NM is 5.1. Number 4 says find XZ. So XZ is the side of the triangle down here. So if we knew its mid-segment, then we can find the relationship, which we can see right there. LM is the mid-segment parallel to it. And we know it's a mixed segment because here we can see it's bisecting both sides. Okay, so that means XZ must be twice as big as LM. So 5.6 times 2, that's going to be 11.2. So these questions are just nice little warm-up ones to make sure you can read measurements on a mid-segment triangle. Number 5, okay, one more, NZ. So let's see, NZ is right here. Let's see. All right, NZ. Now, so NZ is right here. And so you can notice NZ is half of the side. And so here it's parallel to the same LM that we did before. So the two ways to look at that is, so NZ must be what? Well, we already knew XZ from number 4. XZ is 11.2. NZ, based again on the markings, not just by guessing, but by the markings, NZ is half of that. So that means NZ is the same as LM. It must be 5.6. Okay. See if I can erase this. Right. Okay. So 5.6. So that's also crucial. You know that those segments there on the sides of the triangle are also halves. So that means it'd be the same length as its mid-segment. Okay, last 3 are now going to be getting into angles. So number 6 is angle LMN. Let's see. Angle. Let's see if I can. Oh, I erased angle L on, or point L on X. L's right there. All right. So LMN. Okay, so that means we're looking for this angle right here. Well, again, in a mid-segment triangle, you have a lot of parallel lines and transversals. So you want to immediately be thinking alternate interior angles. And so I can see that LM and XZ, and here's the transversal. So that means these angles right here are alternate interior angles. So if N, I'll just call it N, it's MNZ. If that's 29 degrees, then that means that the LMN must also be that. So 29 degrees, angle LMN. Okay, so that's whenever you hear parallel lines, you think, okay, alternate interior angles. Then we need angle YXZ. So we have, let's see, YXZ. So we're looking for this angle right here. And so let's see, can we find a relationship? Well, look, we've got a parallel line right there. NM is parallel to XY. And if we can see the 29 degrees here, it is actually a corresponding angle. These two, this angle here and this angle here, they are corresponding angles. So that means they must be, if you remember back to chapter 3, they must be congruent. So that means that YXZ, just get rid of all my, YXZ must be the same as 29 as well. So we've got another 29 degrees equals angle YXZ. And so that just leaves us with one more, number 8. And number 8 from the book says angle XLM. So we have XLM. So we're looking for this angle right here. All right, and that line let's see, is parallel here. So that is cut by this transversal LM. And well, we already learned that this guy up here was 29. So does that mean angle L or XLM, is that 29 as well? No. You can see that if we look at the transversal, those are not alternate interior. They're not corresponding. They're same side interior. See the stuff we've learned previously. It's still important. So that means 29 and the angle I'm looking for are supplementary. So I need to go ahead and do 180 minus 29. And that's going to give me the angle I'm looking for. And so that is 151 degrees, which makes sense because you can see XLM is a big obtuse angle compared to the 29 degrees. So that means we're going to have 151 degrees equals angle XLM. Notice how much I'm drawing on the picture, and that is if these complicated triangles with multiple sets of triangles and sides and measurements, it can be very confusing, especially when you get to the angle measurements. I really recommend you draw it. Even if you draw lightly in pencil in your book and then erase it, I recommend doing that. But you're going to be very confused if you just try to eyeball it and see all the relationships without, again, where's my parallel lines, where's my transversal? Write those out, and it will be a lot easier and a lot more clear. Alrighty, triangle mid-segment triangle mid-segment theorem. See you in class, and we'll be discussing this there. Bring your questions, bring your excitement. It's going to be fun.